Hello everyone, welcome to the revision lecture series of organic chemistry. In this lecture, we will be discussing the chemical reactions of alcohols, phenols and ethers. This is the part 2 of this chapter. So let's get started with the very first topic, that is acidity of alcohols and phenols. Now, first we have to study about the reaction of alcohols and phenols with metals. So if I react an alcohol with metal, what happens is that I get sodium alkoxide. And what is the formula for sodium alkoxide? It is RONA. This is going to be the formula for sodium alkoxide. Now, if I have a tert butyl alcohol, as you can see over here, that will react with an aluminium to form aluminium tert butoxide. So we can see that they are reacting with metals and they are going to give us a salt. Along with that, there is liberation of hydrogen gas as well. So this is what we are expecting when we are reacting an acid with a metal. If we are reacting an acid with a metal, what happens is that we get a salt and we also get hydrogen gas over there. So the same reaction is happening here also. So we can say that alcohols and phenols are acidic in nature. This is the first point. First reason why we can say that alcohols and phenols are acidic in nature. So if I take another example, here we have phenol reacting with sodium to give sodium phenoxide. That is another example. And here we can see another very important example. If I take phenol and react it with NaOH, I will get a salt, that is sodium phenoxide, and there is elimination of water. Now here you can see we have a base here, and when we are reacting the phenol with a base, we are getting a salt and we are getting water. And what is the general neutralization reaction? If you could remember from the lower classes, the general uh, sorry the general neutralization reactions is acid plus base gives salt plus water. So here I took a base, that is NaOH. I am getting a salt and I am getting water here. So our phenol in that case should be acidic. So this is another example where we can say that phenol is acidic in nature. Let us now see another case. Above reaction shows that alcohols and phenols are acidic in nature. Therefore, we can say that alcohols and phenols, they are Bronsted acids. Now, what do you mean by Bronsted acids? They will donate a proton. They will donate a proton, an H plus, to a stronger base. That is why they are known as Bronsted acids. So, this is very important. Alcohols and phenols are Bronsted acids. Let us now talk about acidity of alcohols. Now, if I consider primary, secondary and tertiary alcohols here, we can understand that the bond, the OH bond is polar, and this polarity of the OH bond is responsible for the acidity of alcohol. Second reason. What is the reason? We have oxygen, which is an electronegative atom, and we have hydrogen, which is an electropositive atom. So this bond is going to cleave because the electron is going to try to pull the electron. All the electrons in the bond are pulled towards the oxygen atom. As a result, this hydrogen can come out as H plus, and that H plus is responsible for the acidity of alcohols. Let us now talk about another reason, that is acidity of phenols. If we see the decomposition of phenol, we can see, or not decomposition, it is splitting. Okay, H plus is moving out, so we get a phenoxide ion here, right? This phenoxide ion is less stable. This is less stable. Okay, sorry, phenoxide ion is more stable, and as a result of which it will help in the ionization of phenol. So that is another reason why phenol is more acidic. So three reasons we have studied. First reason is reaction with metals. When they are reacting with metals, they are giving hydrogen gas. When we are reacting it with a base, what is happening? We get water over there as well as a salt over there. And the third reason is because of the more stability of the phenoxide ion. More than phenol, phenoxide ion is more stable, so it will split up, it will give out the H plus ion. It will we can say polarize or ionize the phenol molecule, and it will release us the H plus, and it will form phenoxide ion, and this phenoxide ion is more stable. Now, for exam, they will ask us questions based on what is the effect of withdrawing group and donating group. What will happen when there is a withdrawing group and what will happen when there is a donating group? Now we have to understand it with a trick. Withdrawing group will increase as acidity and donating group will decrease as acidity. So this is important. Okay, so see here. Here you can see a which. This is a which. Now look at the first two letters of the which. It is W and I, right? So W stands for withdrawing and I stands for increases. So whenever there is a withdrawing group, that will increases the acidity. So the which is having a dog and that is a dumb dog. So you can study D and D, right? D and D. So D stands for donating and D stands for decreasing. So this is a trick. Which has a dumb dog? Which has a dumb dog? So W stands for withdrawing, increases, D for donating, and this D for decreases. Now the next reaction that we are going to study is esterification. Now what is esterification? Esterification is the formation of esters. It is the formation of esters. And how are esters formed? Esters are formed when alcohols or phenols react with either carboxylic acid or acid chloride or acid anhydride. Now, here what happens is that in the case of acid and acid anhydride, in both these cases what is happening, we will be getting the corresponding esters over here, right? And here we are getting R-COOH as the remaining product. And here we are getting H2O as the byproduct. But here in the case of R-COCl, that is in the case of acid chlorides, what happens is that there is liberation of HCl molecule. And since there is a liberation of HCl molecule, we need a base, that is pyridine, to neutralize this HCl. So this is very important. To neutralize the HCl molecule, we need pyridine. Let us now see another very important equation, that is this. Here you can see salicylic acid. Now what is salicylic acid? We have COOH at the first position and OH in the neighboring carbon. That is reacted with this compound and we are getting acetyl salicylic acid. You have to study the formula for acetyl salicylic acid. This acetyl salicylic acid is used for the preparation of a drug and that drug is known as aspirin. So this is a very important equation. So we have to study that acetylation of salicylic acid produces aspirin. Let us now see the next reaction. That is reaction of alcohols with hydrogen halides. So if I take ROH plus HX. Okay, so here you can see ROH plus HX. This is going to give us RX plus H2O. Now, this reaction is known as Lucas test. We have already studied it in the previous chapter that this is Lucas test. Now, this Lucas test can be used for distinguishing primary, secondary and tertiary. Because what is the reason? The reactivity of alcohols, this is very important, the reactivity of alcohols is in the order tertiary greater than, secondary greater than, primary. It is following the order tertiary greater than, secondary greater than, primary. That means tertiary is most reactive towards this particular reaction and primary is least reactive. Secondary is intermediate of tertiary and primary. So we can say that tertiary does not require any catalyst. It can carry out if we take the tertiary alcohol and the corresponding acid in a test tube and simply shake. That much is enough for converting it to an alkyl halide. But in the case of secondary and primary, we must need any catalyst, and the most preferred catalyst is anhydrous Cl2. Anhydrous Cl2 is used in the case of secondary and primary. So if it is reacting comparatively faster, then it is secondary in the presence of anhydrous Cl2, and if it is not reacting that much fastly, then we can say it is primary. Hence it can be used to distinguish between primary, secondary and tertiary alcohols. Next important reaction is dehydration. Now here also we have a very important order, that is this. tertiary greater than, secondary greater than primary. This is the order of dehydration. So tertiary needs minimum reaction conditions for carrying out dehydration, and hence we will use milder oxidizing agents, dehydrating agents such as 20% of H3PO4 and at a lesser temperature, that is 358 Kelvin. On the other hand, if we have secondary alcohol, we need little more stronger conditions for carrying out dehydration. That is why we are using 85% of H3PO4 solution. And in the case of primary, they are least reactive towards dehydration, and that is the reason why we have to use another strong acid, that is H2SO4, and the condition used is 443 Kelvin. So the condition we have studied. Now what is happening in the process of dehydration? In dehydration, there is removal of an H plus from one carbon and OH from other carbon. The carbon onto which the OH is attached, that is known as the alpha carbon, and the carbon onto which the hydrogen is attached just near to the OH containing carbon, that is known as the beta carbon. So we can see that in the presence of these dehydrating agents, these particles are going to move out. What particles are moving out? H2O is going to move out. There is an elimination of water, and that is why the process is known as dehydration. Okay, so this is known as dehydration, and dehydration is basically a beta elimination reaction, because from the alpha and from the beta, compounds are moving out or groups are moving out. That is why it is known as beta elimination reaction. We have already studied so many beta elimination reactions previously, so kindly check the previous videos for that. Let us now talk about oxidation. Oxidation is the most important reaction from here. Now, oxidation is also known as dehydrogenation. What is the reason for that? Reason being, it will eliminate H2. It will eliminate H2 because here we have RCH2OH, here we have only RCHO, here we have 3 hydrogen, here we have only 1 hydrogen. So H2 is being removed, and that is why it is called as dehydrogenation reactions. Now, if we use mild oxidizing agents, alcohols can be converted into corresponding aldehydes. If we use stronger oxidizing agents, alcohols can be converted into carboxylic acids. If we use milder oxidizing agents on aldehydes, then also we can convert it into carboxylic acid. Now, suppose we have a primary alcohol. We have any alcohol, and if I treat it with CrO3, I will be getting RCHO. RCHO is obtained over there. But if there is a compound containing double bond, then we have to use PCC, and PCC is most preferred for primary alcohols. It is most preferred for primary alcohols. Okay, so it does not affect the double bond. That is the most important thing. Now, if we have a primary alcohol, we will get an aldehyde. If we have a secondary alcohol, we will get a ketone. And if we have a tertiary alcohol, and if we carry out the process of oxidation, we can use copper for the process. We will be getting an alkene over here. We will be getting an alkene. So that is important. Okay, there is beta elimination happening over here. This carbon onto which the OH is attached, that is going to be the alpha carbon, and this is going to be the beta carbon. So from these two, we are moving a water molecule, and the process is called as dehydration. So copper at 573 Kelvin, in the case of a tertiary alcohol, is going to carry out dehydration and not oxidation. That is important. Okay, so copper can be used for converting primary alcohol to aldehyde and secondary to ketone. So we studied so many reactants here. Okay, so many reactants we have studied here. Oxidizing reagents. First one was CrO3. CrO3 can convert into aldehyde, so it is a milder oxidizing agent. Now we have already studied about KMnO4, right? In the topic of alkanes also we have studied. KMnO4 is a strong oxidizing agent, and as a result of which it can directly convert it into an carboxylic acid. So that is important. Another important reagent that we have studied is PCC. Another important one is copper. Okay, so these are some of the important oxidizing agents that we are studying over here. Now you can download a special organic revision note which we have uploaded at the NEETshala app. You can go to the NEETshala app. In the concept booster series of chemistry, you can get this note. where we have included all the oxidizing agents, all the reducing agents together. So it will be really helpful for your NEET preparation. So let us now talk about the reactions of phenols. We have finished with the reactions of alcohols. Let us now talk about the reactions of phenols. The first one is electrophilic aromatic substitution. Now, phenols are ortho-para-directing. The OH group is ortho-para-directing group, right? We have already discussed about that in the benzene part. It is ortho-para-directing group. So if I use dilute HNO3, that is going to carry out the process of nitration. We do not require H2SO4 here. What is the reason? Is because we have the OH group, which is a strong protonating group. It can protonate the dilute HNO3 to give NO2 plus. Now what do you mean by this protonation? Protonation basically means that if I have HNO3, this HNO3 is going to give me NO2 plus H plus. This process is called as protonation. So in the case of benzene, we can say that we need some agents, right? What was the agent that was used? H2SO4, right? But here we have OH, and this OH, in the presence of this OH, so you can consider this phenol as a Vishwamitra. Okay, so whenever this HNO3 is there, he is scared of Vishwamitra. So if there is any other saint, poor saint is there, means the compound is not at all scared of him, and he needs some other people to get protonated. But in the presence of strict persons like Vishwamitra, what happens is that they will carry out the protonation on themselves. So they will give us NO2 positive, right? They are going to give us NO2 positive, and this NO2 positive will be substituted at the ortho and para positions to give the corresponding products. Now, how can we separate these two, ortho and para products? It's very simple. If I take the ortho product, we can say that they have intramolecular hydrogen bonding. Whereas in the case of para-nitrophenol, there is intermolecular hydrogen bonding. Now, whenever there is intermolecular hydrogen bonding, two people are held together. Two people are held together. So when two people are held together, they are very good friends. So one friend does not want to leave another friend, right? So they are not at all volatile, very less volatile. Whereas even if there is intramolecular hydrogen bonding, the hydrogen bonding is present within the same molecule, so there is no problem in volatility. So this is volatile, this is less volatile, so we can easily separate them by steam distillation method. So this is important. They can ask, what is the method used for separation of ortho and para isomers of nitrophenol? So that is important. Now I used dilute HNO3 for carrying out the reaction of nitration. What if I use concentrated HNO3? If I am using concentrated HNO3, I will be getting picric acid. What is picric acid? 2,4,6-trinitrophenol. So in three contexts you are studying picric acid. What are the three contexts? Last chapter we have studied. If I have Cl here, NO2 here, NO2 here, okay, this is benzene, and here also I have an NO2 group. So how to convert this into picric acid? We have already studied, right? We have to treat it with NaOH. So heat it, we will be getting picric acid. This was the reaction that we studied in the previous chapter. And now we have studied here, treated with concentrated HNO3. But the yield of this reaction is very poor. So what should we do? To increase the yield, what should we do? First, we have to carry out the sulfonation. For sulfonation, what we should do? We have to treat the phenol with sulfuric acid. We have to treat the phenol with sulfuric acid, and we are getting this compound. This is the compound that we are getting. And to this compound, this is known as phenol 2,4-disulfonic acid. Okay, this is known as phenol 2,4-disulfonic acid. Now, this we have to treat it with concentrated HNO3. So when we treat it with concentrated HNO3, we will get picric acid. So this is mentioned in NCERT, and they have asked to write the equation. So you can write it now easily, two-step process. So this is important. Let us now talk about the halogenation. Now halogenation also, earlier we need a Lewis base, right? We need a Lewis base for the protonation. Br2 should convert to Br plus Br minus, and this Br plus is required for carrying out the process, right? Process of halogenation. But here, since it is phenol molecule, the Br2 is also feared of our Vishwamitra. So what is happening? It will get protonated easily. So we will carry out it in the presence of a low polarity solvents such as CHCl3 or carbon disulfide medium. So these are low polarity solvents at low temperature. We will be getting ortho and para products over there. Now what if I am treating it with bromine water? If I treat it with bromine water, what happens is that I get 2,4,6 tribromophenol. 2,4,6 tribromophenol. This bromine water is reddish brown in color and this is going to be white in color. So this can be used as a distinguishing test for phenol. Now this is a question given in NCERT. Write the structures of the major products expected from the following reactions. Mononitration of 3-methylphenol. So there is a methyl group present, so it will come like this, right? The para product will be obtained over here. Now if we have dinitration, what happens? Then also we will get ortho and para product over here in the first case. Second case, there is dinitration. If it is dinitration, we will be getting both ortho and para position will be filled. Now another one is mononitration of phenyl methanoate. So when we have mononitration of phenyl methanoate, it will come only in the para position. So this is important. Let us now talk about the Kolbe's reaction. Now whenever we hear about Kolbe, remember that we need CO2. We need CO2 in his reaction. He is very fond of CO2. So here what happens? We have phenol treated with NaOH. We will be getting sodium benzoate, and we have to treat it with CO2. We will be getting salicylic acid. We are getting salicylic acid. So this is known as Kolbe's reaction. This is important. They can give directly this equation and ask what is the reaction. Now here we have another very important reaction, that is Raymer-Tiemann reaction. In Raymer-Tiemann reaction, what happens is that this compound will react and it will form CCl2. This is the electrophile in the reaction. Carbene. Dichlorocarbene is the intermediate, or we can say the electrophile. This is the electrophile. And what is the intermediate? They can ask what is the intermediate. Intermediate is known as benzyl chloride. It is not benzyl chloride, it is benzyl chloride. This benzyl chloride is now treated with NaOH. So we will be getting this compound over here. And finally we have to treat it with any of the acids. So we will be getting salicyl aldehyde. We are getting salicyl aldehyde over here. Okay. So this is known as Raymer-Tiemann reaction. They will give the reaction directly and they will ask us to identify the reaction. So this is very important. Named reactions are very, very important. Let us now talk about the oxidation. This we have already studied. Reaction with zinc dust. When we are treating phenol with zinc dust, we will be getting benzene. Already studied in hydrocarbons chapter. Now, what about oxidation? Oxidation is carried out. Oxidation of phenol is carried out by using Na2Cr2O7. So this is another oxidizing agent. Important. So this will give us benzoquinone. Benzoquinone. Next is the chemical reactions of ethers. So when we talk about the chemical reactions of ethers, the first one is reaction with HX. What is HX? HX can be HCl, HBr, anything. And what is the order of reactivity? HI greater than, HBr greater than HCl. This is the order of reactivity. So what happens when we are treating an ether with HX? When we are treating an ether, that is ROR dash plus HX, what are we getting over here? We will be getting R dash OH. This group will go with this R dash O and H, plus we get RX over here. Now the most important thing is that they will give one group as tertiary. This is the most important part. If they give one group as tertiary, then we have to take it as we have to add the halogen atom to the tertiary side. That is the most important point. We have to add the halogen atom to the tertiary side. This is the most important question that we can expect from here. Okay, so let us now talk about the next reaction, that is electrophilic substitution. In electrophilic substitution, again we have to study that OR group. That is, it can be OCH3, OC2H5, all these type of groups can be present. These are again ortho and para directing group. And since they are ortho and para directing group, whenever we are carrying out halogenation, we will be getting para and ortho product, and para is the major product. Now look at the reagent here, Br2 in ethanoic acid, we are taking low polarity solvents again. Friedel-Crafts alkylation and Friedel-Crafts acylation. Here you can see we are getting ortho and para products in both cases, same as that of benzene. There is slight difference, that is we have to carry out these reactions in CS2 medium, that is the only difference. So last one is nitration. Nitration, here we have to use H2SO4 and HNO3 because OCS3 is not that much polarizing group. It is not that much strict as our phenol group. So we will be getting the same products over here, but the mixture is important. Mixture is important. They can ask about the mixture. So this completes our chapter. Now let us do some of the questions related to this chapter. NEET 2018 question. Compound A on treatment with sodium gives B. Okay. With PCl5 it will give C. B and C together to give diethyl ether. A, B and C is in the order. So here if I am checking the options, 3 options are saying C2H5OH and 1 is saying C2H5Cl as A. So let us take both. First let us take C2H5OH and let us treat it with sodium. Will the reaction occur? Yes, reaction will occur. We get C2H5ONA, right? C2H5ONA is obtained. Next, what are they saying? If I treat this C2H5OH with PCl5, I will be getting C2H5Cl, right? C2H5Cl. Now they are asking me to react this with this. So there we are getting C2H5 or C2H5. What is the process? The process is known as Williamson's ether synthesis, right? Williamson's ether synthesis. So the answer should be A should be C2H5OH. So we can eliminate this option because that last one does not react with sodium. So that cannot be the answer. So next option should be C2H5ONA because that we are getting over here as B, and C we are getting as C2H5Cl. So the answer should be option number C. 3. Now for doing this question we can use the trick which has a dumb dog. So here you can see that CH3 is the group present. CH3 is the group, means it is a donating group, so it will decreases, right? It is decreasing. So the order is going to be this. Phenol is going to be more acidic, and then we have the meta, ortho and para. Now remember that whenever we have groups like CH3 which is donating group, whenever we have donating group it will follow the order MOP, meta, then M, P and O, meta, then para and least for ortho. And in the case of withdrawing group it is OPM. This is the order, decreasing order. Next, OCS3 is treated with CH3Br and FeBr3. What is the major product? Very simple question. We just have to add. This is a basic process of alkylation. So we have to add CH3 group to the para position because para is the major product. So it is option number 4. Next, this is an important question. Usually what happens is that everyone will do it like this. This group is going to go with H, so they will form CH3 CH2OH plus CH3I. This is the first product. Everyone will get up to that, and they will stop with option number 2 because option number 2 says CH3I plus CH3 CH2OH. They have given that HI is taken in excess. Now since it is taken in excess, what we should do is this one again we have to treat it with HI because there is a possibility that alcohols can also react with HI, right? So we have to carry out that reaction because even after doing the first round of reaction there is enough of HI left for carrying out another round of reaction. So when we are carrying out another round of reaction, what is happening? We get CH3 CH2I. So we get CH3I as the first product and CH3 CH2I as the second product. So the answer should be option number 3. Let us now talk about the next question. Here, what is the product A is asked. So in the first step, what is happening? Nitration is carried out of benzene. So we get nitrobenzene. Treated with SN plus HCl, we get aniline. We will study this reaction later. And next we have to carry out diazotization. We get benzene diazonium chloride. and that is treated with H2O, we get phenol. Next, identify the major products PQR in the following reaction. So first we have to treat this with anhydrous AlCl3. So what is the process? The process is going to be this is the compound, so it is alkylation. It is alkylation, and after that we have to carry out oxidation. Okay, so let us see the process here. Here we get this compound over here, and now we have to carry out the oxidation, and we get cumene, right? This is known as cumene. So cumene is carried out oxidation, and we are getting cumene hydroperoxide, and then we are carrying out the hydroperoxide rearrangement to give us phenol, right? So this is important. Now here the thing is that people make mistake in this part, right? So I will do that again. What is the compound that is given for us? Here it is CH3 CH2 CH2 Cl. So CH3 CH2 CH2 Cl, what is happening? This is going to react with AlCl3 to form AlCl4 minus and CH3 CH2 CH2 with a positive sign. Now this is a primary. Let us check whether there is any possibility for getting a secondary. Yes, if I am shifting one hydrogen from here to here, I will get a positive sign over here, so I can remove this over here and I can add a hydrogen over here, right? So this is what I am getting over there. We get a secondary carbocation that is more stable. So this secondary part is going to substitute on the benzene ring, and as a result of which we are getting this compound over here, cumene over here. And now this is carrying out oxidation. So what happens? Remove this H and we have to add OOH. Now what we should do, this much part we are removing, and OH we will keep it as such, so we get a ketone also, that is propanol. Now let us talk about this question. Which of the following is the most acidic compound? It should be option number 4. Heating of phenyl methyl ethers. Phenyl methyl ether means this is the compound. So what happens is that this group is going to go with I. So this is the product that we are getting, and the answer should be phenol. Next, what is this reaction? Yeah, this type of questions we can expect plenty of questions for the NEET exam. What is the reaction? First step, we are treating with NaH. We are getting RONA. This is of general form, RONA, and MEI is same as CH3I. So that is treated with RX. RONA plus RX. It is Williamson's ether synthesis. So option number 2. Among the following ethers, which one of the following will produces methyl alcohol on treatment with hot concentrated HI? So whenever I have a tertiary, I told you that this will go with the iodine. So the other one will go with OH. So it will be CH3OH. Methyl alcohol is produced in the case of option number 2. Next, this question we have already done. And let's see this question over here. Which one of the following compounds has the most acidic nature? First one is CH2OH. This is phenol, right? So phenol is most acidic among the following. Anyway, it cannot be these two. Here we have CH2OH and this one. So due to inductive effect, we can say phenol is the answer. Which one is the most reactive towards electrophilic reagent? So whichever is having higher electron releasing effect, that is going to be showing electrophilic reagent, more reactive towards electrophilic reagent. So the answer should be option number 1. Now the next one is para-nitrophenol. We have to find what is the acidity order. So if we talk about the acidity order, I have told you that whenever we have, here we have methyl group, here we have nitro, and here we have nitro. Nitro is a withdrawing group, and CH3 is a donating group. So whenever there is a withdrawing group, it will increase us, right? It will increase us, and donating group will decrease us. So what could be the least? Least could be this. It could be least because it will decrease. Then comes phenol. So B should be the least. Then comes phenol. Sorry, this is the symbol. Then comes C because meta will come. and least will be, sorry, maximum will be for para products, so it should be D. So D, C, A, B, option number 1 is correct. Yeah. So with this, we are concluding this chapter, alcohols, phenols, and ethers. In the next lecture, we will be taking up the chapter aldehydes, ketones, and carboxylic acid. The long chapter, lengthiest chapter of organic chemistry, aldehydes, ketones, and carboxylic acid, we will be taking up in the next lecture. So see you again in the next lecture. Till then, goodbye and happy learning.